So here the name of chapter 11 is work and energy, and the first topic which we will discuss in this chapter is concept of work. We all familiar with concept of work, and everyone in everyone's family, parents are working. You must also you are also working to help your parents. But this concept of work in physics is a little different from the concept of work in our real world. Like for example, I am teaching in a school or I am taking a lecture, I am doing my work, I am doing my job. But in terms of physics, work done by my is zero. Because in physics, when we talk about work, we talk about mechanical work done. So concept of work in physics is very interesting, and work is defined as work is said to be done if the object actually moves in the direction of applied force. I'll give you an example here. Like if there is a block having mass m and some force is applied on this block F, and under the action of this force this block has moved some distance, or it is displaced by d, then work is defined as F into d. So as you are observing that there is a mass m and a force F is applied on this mass, and this mass has moved in the direction of applied force, then we can say work is done, and work is defined as product of force to the displacement in the direction of force. So formula of work is force into displacement. How can you define work then? We can define work is said to be done when an object moves in the direction of applied force. So this is your basic concept, that work is said to be done when object is displaced or moved in the direction of applied force. And how to calculate work? For that we are having formula W is equal to Fd. So we can also define that work is equal to applied force multiplied by displacement covered in the direction of force. So when your object is moved in the direction of force, work is said to be done. What is unit of work? Let me discuss with you. So SI unit of work is Joule. We write it in small letters as it is named after physicist Joule, and the symbol of the unit of work is capital J. So when we can say that work done is 1 Joule? So after understanding the definition of work and with the formula of this work W is equal to Fd, we can always define 1 Joule of work. So consider if your 1 Newton force is applied and displacement is 1 meter, then your work is said to be 1 Joule. So let me write that definition for you. So here is the definition of 1 Joule of work for you. In this equation you can see, if I'll put value of force 1 Newton and value of distance 1 meter, then I will get 1 into 1, that is 1 Newton meter or 1 joule of work. This Newton meter and joule, they are same thing. There is no difference. Newton meter or what this I had to one joule or 1 Newton meter. So this 1 Newton meter or this 1 joule are the same thing, and the Newton meter itself is known as joule, and by this formula if we will make F 1 Newton and D 1 meter, then work will become 1 joule. So how do you define 1 joule of work? 1 joule of work is said to be done when under application of 1 Newton force an object moves 1 meter in the direction of applied force. There is also a concept associated with the work, that when the work is zero, or when the work is positive, or when the work is negative. So in this class, let me discuss with you one more point, that when the work done is zero, and then about positive and negative we will discuss in next class. Okay. So what are the conditions of zero work done? There are two main conditions when your work done is zero. As we know that W is equal to F into D. So the first condition is, if your displacement is equal to 0, your work done is going to be 0, because anything multiplied by 0 will give you a 0. And when would this happen, that displacement is equal to 0? So there are two things. The first, that if an object does not move at all, if it is placed at A and after application of some force the object is still at A. The example is very simple, like if I am pushing this wall, then even after applying force the change in position of wall is 0. So doesn't matter how much hard I will try, work done by me is 0, because the displacement is 0. The second case for having D 0, if an object A starts from a point and then after completing some round, doesn't matter, and comes back to point A. So as we all know that displacement is defined as change in position. So as it is coming back to the same position, so displacement becomes 0. So for example, when I am standing here and teaching you, and I move and take the round in the classroom, and or even after 1 week after doing so much work, if next week again I am standing here delivering you lecture from the same spot, then my D is 0, and according to physics, work done by me is 0. I hope you got this point. And the second case which I am discussing, for which your work done is 0, when the movement or the displacement of the object is not in the direction of force. For example, if this is an object, and if this object is moving in this direction, upward direction, while we are applying the force in the positive x direction, and then we know that the angle between displacement and force is 90 degree, so we can say that the object is not moving in the direction of force, hence work done is equal to 0. I will give you the most common example of this 0 work done on the basis of angle, which is there in your syllabus. If an object is moving in a circle, then work done by object is 0. Why? Because at any point, if you will consider, for keeping an object in circular motion, a force is required which is known as centripetal force. A centripetal force towards center is always required for keeping an object in circular motion. And you know that direction of the force, direction of the motion is always along the tangent of the circle. So direction of the motion is always along the tangent of the circle, and there is an angle of 90 degree which is always there between applied force and the direction in which object is moving. So when an object is moving in circular motion, then also work done by an object is 0. or work done by external agent on that object is 0. So even for the part of a circle, if it moves from point A to B, we can say the work is 0. And if this particle will complete the circle and will come back to this point, then according to discussion in first point, D will become 0 and our work will also become 0. So for complete circle it is 0, D is equal to 0, and for the part of the circle, due to the angle 90 degree, object is not moving in the direction of force, work done is 0. I hope you got the crux of this lecture. Anyhow, if you are having any doubt, any queries, I will be taking your live class at Zoom session and we can discuss our doubts there. And the concept of negative work I am going to discuss with you in next class. Till then, take care, stay safe and see you soon. And like always, thanks for watching. Bye bye.